tonight by Jeff Kanipe. And I said that correctly, I hope. Very good. Jeff's been a science journalist for 35 years, specializing in cosmology and astrophysics. He's the author of Chasing Hubble's Shadows, The Search for Galaxies at the Edge of Time, The Cosmic Connection, How Astronomical Events Impact Life on Earth, and A Skywatcher's Year. He's co-author of the ARP Atlas of Peculiar Galaxies, A Chronicle and Observer's Guide with Denis Webb, and Island on Fire with his wife Alex, who is here. She's a science writer. Jeff has worked as a top editor for Astronomy and Stardate magazines and written for numerous publications, including New Scientist, Nature, and Sky and Telescope. Jeff and Denis have been producing an ambitious, unparalleled multi-volume series called Annals of the Deep Sky, a survey of galactic and extragalactic objects. And I thought I saw one of those books here. Which one is that? Oh, there's a couple. Oh, there's a couple of them here. Okay, and I see John's got a couple of them up there. Hailed by Richard Berry as the sky guide we've been looking for, Annals is an up-to-date observing manual for amateur and semi-pro astronomers, which features in-depth astrophysical profiles of stars and deep sky objects, historical and biographical background, as well as observing advice for amateur astronomers of all expertise. Sky and Telescope named Volumes 1 and 2 as hot products back in 2016, plus Volume 3 in 2017. Volume 5 covering the constellation Centaurus through Cepheus. I hope I said Cepheus right. Cepheus. Tomato. You say tomato. Was published last fall, and Volume 6 is expected to be out before the end of this year. So when completed, the series will comprise all 88 constellations, so it should be a nice set. Jeff's a member of the American Astronomical Society and its Historical Astronomy Division. He received his Messier Certificate, number 55, back in 1969, while a member of the Corpus Christi Astronomical Society. Asteroid 84447 Jeff Kanipe is named in his honor for his role in identifying the earliest known image of that asteroid. Jeff and Alex live in the foothills northwest of Boulder. Jeff's presentation, Annals of the Deep Sky, Object Selection by Design and by Hunch. We'll talk about the particulars of object selection for Annals of the Deep Sky. And Jeff comments that it's not as easy as you might think. He's going to discuss how a writer goes about trying to determine which of all the celestial objects in the night sky have stories rich or scientifically detailed enough to investigate. So with that, Jeff, you have the floor. Out in there. Okay. All right. Well, good evening. Happy Mars opposition to all you Martians out there. Thanks for asking me to speak this evening. I'm getting kind of a warm and fuzzy feeling because this reminds me of the first astronomy club I was ever a member of, and it was in Corpus Christi many, many years ago. And so I got this kind of warm and fuzzy feeling. Everybody's so friendly. Nobody's snobby or stuck up. It's very nice. So anyway, it's a pleasure to be here. Someone suggested that I might talk about some aspect of our book, Annals of the Deep Sky, which you may have heard about, and to my great relief has been well received, and based on questions we're often asked about. I think I have something that a topic you might even enjoy if I speak about it tonight. As a preamble, you might be interested in knowing that it took us nearly 8 years to get out the first 2 volumes. Not because we were slow or because we were winging it or anything. It's just that there are a lot of moving parts that go into any book, and this is from scratch. So we had to come up with a format, we had to come up with style, everything. And it took that long to write, design, format, and publish volumes 1 and 2. At any rate, with a system now more or less in place, we've since endeavored to produce a new volume every 9 months. But I've discovered that, like producing a workable healthcare plan, who knew it could be so complicated? It's hard work, and you can easily get lost in the details and find yourself down the rabbit hole, which is often.
My wife Alex tells me that I've talked about accretion disks and red giants in my sleep. And then in reoccurring nightmare, I'm trying to fix a mechanical thing. And the more I try to repair it, the more broken it becomes. So there are days when working on Annals is similar to my nightmare. But we've persevered through 5 volumes. A 6th is on its way, and I think I can tell you safely that it should be out by December, maybe even November. But as I said, we're asked a lot of questions, and we may even hear some of them here tonight, but I will warn you that they probably won't have any answers that you will find satisfactory. So there is, however, one question I can answer pretty well, and that is, how do we select the objects that we choose for profiling? I call every object I feature in the book a profile. And the answer to this question touches on many overarching aspects of content selection, but it is also instructive in its own right, in that it often takes us down the proverbial road less traveled, where you find some interesting things and surprising things. So rather than taking a prescriptive algorithmic approach, our selection process is an application of both convention and hands-on heuristics that I call by design and hunch. I'm afraid to touch your computer because, it's her computer, it's not mine. Yes. So the by design approach is easiest to explain. Objects in this category are prevailing no-brainers. They're the bright, popular objects of universal interest, Messier objects, bright NGC objects, and such. Famous double and variable stars, and other conspicuous celestial showpieces. They also have a rich historical background, and I'm really big on history. You'll always find some historical aspect of most of the objects in here, if it exists. So you can't ignore something like this guy, M51, the Whirlpool Galaxy, Canis Venatici. Now on the downside, these objects are so popular, they're almost too popular, and tend to be over-observed and done to death. I mean, you go out with your telescope, the Orion Nebula is up, you got to look at the Orion Nebula, right? You would probably not look for M78, but you're going to look for the Orion Nebula. And so this is the problem, the downside of this. On the other hand, you cannot argue that their astrophysical details, their nature, are equally well known. And this is where we think Annals shines. Popular stars and deep sky objects may look like old friends, but you may be surprised what they've been holding out on all these years. The objects you see on the surface, almost every deep sky object, even stars, vary structurally from wavelength to wavelength, sometimes dramatically. And as we see the upper left up here, M51 doesn't exactly resemble its visual appearance when you look at it in X-rays, ultraviolet, and infrared wavelengths. And when multi-wavelength observations and skilled photo processing are combined, as they are in the lower right, that is the lower right, yes, the galaxy and its surroundings indicate a larger canvas of past interactions and disturbances that shape its so-called circumgalactic environment. So M51 is a no-brainer, and in it goes, and it's got a lot of history, a lot of observations, and a lot of astrophysics that can be related to other galaxies. So that's the by design approach. The by hunch approach is not so easy to find because it is subjective, though not totally so. Visual magnitude has nothing to do with the choice, as said object may be beyond the reach of anybody's telescope, may not even be visible in a telescope. Popularity doesn't come into play because it may be found in another hemisphere or is somewhat off the beaten path. The primary criterion for the hunch category is the object has to have a story, an instructive story to tell. And that's why we include it. Now, what do we mean by story? The truth be told, virtually all celestial objects have a story to tell. They've got something to relate that's interesting. But not all stories, not all of their stories, just like fictional tales, are of deep interest. Some are more interesting than others. So let's take the case of this guy here. It says IC 1613. You might not even know about it. It's kind of snuck past my radar too. It's a dwarf irregular galaxy in Cetus, and it's lying at a distance of only 2.4 million light years away, so it's in the galactic neighborhood. It's right nearby. It's extremely faint, even in an 18-inch telescope. You can see some of this, the H2 regions, these pinkish regions up there in a telescope that size, but everything else is it's all lost in the grain. The story of this galaxy is that it has a low metal content. Low metal being that it appears to be in a primitive state. The subsequent generations of stars have not been born to significantly enrich the galactic environment, so it's low metal. Low metals are primitive universe, high metals are recent and more enriched universe. So we might say that the moral of this story is that its existence challenges current theories about how stars form in dwarf galaxies in the local neighborhood and be as nearly as old as the universe, because its age is between 7 and 10 billion years old. So here's another example. This one's not too obscure. This is NGC 6741, located in Aquila, and is known popularly as the Phantom Streak Nebula. But it's also difficult to observe in a telescope less than 18 inches. The story here is that we're looking at a young, still developing planetary nebula. It lies at a distance of about 2,000 parsecs, that's 6,500 light years, with a hot central star of some 180,000 kelvins. It's really hot. So as can be seen in this image, there are a number of dusty features crossing the nebula's external layers. See them going this way and that way, across the main axis. And there's some radial rays and arcs also seen along the outer edges. So there's a lot going on. Obviously, this is a very active object. Something's going on. So these features would make this planetary an interesting object anyway, just by itself. But if you can look at the substructure, you'll see something else that makes it even more interesting. And what's going on that you cannot see. Unless you do something clever or use some ingenious visual technology. So let's unpack this image. This is a kind of a busy image here. The HST image at upper left shows the bright arcs. You can see from the, it's even labeled for you, bright arc. And that form the rim of the nebula. The HST inverted infrared image at upper right reveals the nebula's outer halo, which consists of material ejected from previous outbursts. Planetary nebula, for those who don't quite know what a planetary nebula is a sun-like star like our sun, in its death throes at the end of its life. And in the end of its life, it expels gas. And if you've ever seen pictures of the Ring Nebula, then you've seen a planetary nebula, and the little hole in the center is because winds from the dying star, which is now a white dwarf, have blown off matter. And that's what's just beginning to happen with this object. It's just beginning. So we're catching it in the act, which is really cool because a lot of planetary nebulae only live, their extent of the lifetime is 50,000 years. There aren't that many of them because they live so short a time. So to see one in its formation is what makes this really cool. Now, the two lower panels are based on ESO and ground-based spectroscopy, and it reveals the nebula's three-dimensional structure. Now, I don't know if this will work from where you're sitting, but it works on the page anyway. If you cross your eyes until the dots converge, those dots, then you can better see the three-dimensional structure. And I've been waiting for this moment because I want to see everybody crossing their eyes. Yeah, but you can see it on, that's right. It works on the page, but it doesn't kind of work on the screen, I don't think. It works from here. Anyway, so the point of all this is that when you combine what you observe in a telescope, that you see in the eyepiece, with a filter or without filter, with what these penetrating observations show, your observing experience just got that much better. That's the theory. Similarly here, this is NGC 5466 in Bootes, not a stunner, not like M13 or Omega Centauri, but it has a secret. It's sporting a lengthy tidal tail, which you can't see unless you use H1 observations, neutral hydrogen. Tracing the tidal tail back 100 million years has allowed astronomers to determine that it moves along a highly eccentric retrograde orbit. It took it through the galactic disk about 50 million years ago. So although you might be tempted to skip this cluster because it's kind of it's not like M13, you know, you'd be missing out on what is interesting about this object. You'd be missing out on an important kind of a lesson, a moral tale, if you will, about astrophysics. It's a globular from another galaxy. It's not of this galaxy. It was taken from another galaxy that no longer exists. So, yeah, admittedly playing a hunch on which objects will be of interest to most people is a risky thing. An object that I find personally interesting may be your sedative, something you're not that interested in, or you go, well, why should you even talk about this? On the other hand, though, you may not realize just how interested you are in such an object until you approach it with the attitude of observing something that you didn't know before. So you have keeping an open mind. And now we've got a couple examples here that I'm going to try and keep you awake for. Everybody knows who Clyde Tombaugh was, I presume. He was a discoverer of Pluto. He also discovered a lot of deep sky objects, two of which are up here, Tombaugh 1 and 2. And I profiled these two open clusters in Canis Major. Both are rather ho-hum. Tombaugh 1 is probably the most pedestrian. It's moderately populated, doesn't have a central concentration to speak of. Tombaugh 2, though, is more interesting visually, but it's spectroscopic analysis that really brings out the interesting thing about this cluster. And that it is that it harbors two different populations of stars, young and an old. And these are based, again, on metal content. The metal poor population is in the center, and the metal-rich groups in the outside. So what's interesting is that this would be the first, and it's confirmed, and it's been pretty much proven, this would be the first time we've seen two different populations of stars, old and young, in an open cluster in our galaxy. Now, in the Large Magellanic Cloud, there are a lot of examples. So take a look at Tombaugh 2, just take a look at it, and then I'm going to show you one that's in the Large Magellanic Cloud, and you'll see they look very similar. Boom. NGC 1854. It's considered actually a young globular cluster. We all tend to think of globular clusters that have existed since practically the beginning of the universe, 12, 11 billion years ago. But these globular clusters are both young and old, which is kind of screwy, but it makes things more interesting.
Did you get that from the colors of the stars, the red ones and the blue stragglers?
Yeah.
Both together in the
Yeah.
same cluster?
Colors, the discerning thing. So these kind of objects make great astro images. Beautiful. You sit there and go, wow, that's pretty. But not so much our next category. Telescopic asterisms. I had no interest at all in telescopic asterisms. But I was sort of educated by people who said, well, look at this, look at that, look at that. And there are people who actually keep catalogs of these things. They go out and actually look at that little strange looking V-shaped group And Herschel, when he saw it, he discovered it in 1785, he thought that it had some nebulosity around it. Probably he needed to recoat his mirror. But as you can see, the SDSS image here clearly shows it's just a little clunk of stars. So I must admit that I underestimated the interest people have in these quirky little patterns of unrelated stars. But that's what they want, so they go in. The other more famous asterisms that we probably know would be Camelos Cascade and Camelopardalis. That's NGC 1502 lying over there on that side. Open cluster, that's an interesting object too. And the coat hanger, aka Colander 399 in Vulpecula. And because of their angular size in the sky, though, they're both best appreciated in binoculars. But when I think of asterisms or conventional asterism, I think of this. But I don't think of that. Now that's a curious little thing, isn't it? It's got an NGC number, NGC 2433. It's a curious little triad, stars that may or may not be physically related. I can find very little about this object. I've looked and looked and looked. Harold Corwin, some of you people might know his name. He's an NGC scholar, and other NGC scholars refer to it as a triple star, which it could be considered visually. That doesn't mean that those stars are all in the same proximal space. The last time I looked at Simbad, which is the Washington Double Star Catalog doesn't even list it. Last time I looked at Simbad, it was listed as a double or multiple star, while the NASA IPAC Extragalactic Database, or NED, chalks it up as other. Very clever, other. I could just see them sitting back going, other. So it was discovered by John Herschel in 1828, calling it extended and faint. So I don't know what this is. I really don't. But in any case, I played a hunch and included it in the Annals, thinking that at least it might interest readers who perhaps are fans of Mickey Mouse. Now, I've got to get my little pointer out here. These are two obvious choices, right? They have to go in. North American Nebula, the Pelican Nebula. Absolute no-brainers, no question. But sometimes you get so wrapped up, so absorbed in marveling over the big picture, you fail to see an intriguing detail lost right down in the grain. So check out this little object right there. See that little guy? Now we'll go close up. Now when I first saw a close-up of this object, it reminded me of a flea. Pareidolia gone off limit. And that's what I call it. I call it the flea. It actually has some 22 other formal identifiers, including 3C423, which would make it a radio source, and GRS for galactic radio source, 84.00 plus 00 plus 80, very memorable identifier. I've shortened the last identifier to an easily remembered GRS 84. So this is actually a compact H2 region floating off northwestern edge of the Pelican Nebula. You can see a small clutch of embedded stars in the narrowband infrared image right here. So this bright star is this guy, and then the other stars are embedded in here, and they're not seen until you look at it in infrared. The star that's held by the flea's proboscis is a 10th magnitude G-type foreground star. So it's in the foreground. It's not at all associated with this nebula. It doesn't have a IC or a sharpless or lens bright nebula identifier, which is surprising to me because its surface brightness is at least as bright as the brightest parts of the Pelican Nebula. So it's kind of become a hobby horse for me. I've only seen one paper on this object, and actually two papers that place it about 4 kiloparsecs. That's 4,000 some odd parsecs out, and consider it an H2 region, but there's nothing else on it. And I've been trying to get amateur imagers out there to shoot this thing, because there are no images on. You go on the web and you look for it. There's one, what the heck is this image, from some guy in Slovakia or something, and nothing else. Anyway, this went in, for better or for worse. This went in too.
What's the magnitude of
I have seen it with my 11-inch, and it's just almost transparent at about 240 power magnification. A little better than UHC, but I couldn't give you a magnitude, other than the fact that that's a 10th magnitude star, and then it's about 2 by 2 arc minutes. It's a very small object. So I encourage people to go out there and take pictures of this thing and get them back to me so I can put them in the book. All right. I think I just skipped one. See, your computer's got a demon in it. Here we go. All right. So, bottom line, we choose our object either because common sense dictates that we do. It's an M object, bright NGC object. It's popular. It's called the whatever nebula. Then it goes in the book. That's the easy part. The other part, the not so easy, or hunch part, is just not that. You're often in a zone where you really have to sound other people out, do a little research. Sometimes I'll look up the object and look at all the papers. If there have been a lot of papers written about it, then I'll do it. I wish they could all be as convincing as NGC 4921 here in Coma Berenices, or as stunning as the core of M100, which is a grand design spiral with prominent, well-defined arms, laden, those blue patches with star-forming regions. That's easy. That goes in. And actually, today, I was just sitting back and hearing people talking about the kind of telescopes they were using, their observing reports, 12-inch here and a 13-inch here. And it's like we suffer from an embarrassment. It's not suffer at all. We enjoy an embarrassment of riches when it comes to choosing objects that we want to observe or profile. That wasn't always the case, as some of you people out there I suspect you're close to my age might know. Once upon a time, an amateur astronomer could only dream of buying or building a 6 or 8-inch telescope. And even then, you were restricted to visually observing the brightest objects. But amateur astronomy has come a long, long way in the last 50 years in the fact that telescopes are more expensive. Amateur astronomy, though, amateur astronomers are not only want to know what objects look like through telescopes. That hasn't changed. They want to know why they look the way they do. And I've seen this over the years that I've been in this business, and I've seen much more interest from amateurs say, well, why does it do that? Why is it shaped like that? The only way you can explain it is to get into some astrophysics. It's not as bad as it sounds. We try to make it as harmless as possible. But this kind of interest, this desire to dig into the nature of celestial objects, partly explains the abiding popularity of Robert Burnham's Junior Celestial Handbook. The Dover edition of which is now in its 40th year. The book itself was, I think, in paper format in 1966. So we at Annals salute this kind of book. Really, this series is the first of its kind. If you think about it, Even if you look back to all the earlier observing guides, Webb or Smythe, they talked about how something looked visually, but they didn't talk or couldn't talk about why it looked the way it did. This was the big deal. Herschel, William Herschel, John Herschel, had an ongoing discussion about what is a nebula. Is it stars or is it gas or what is it? They didn't know. All they could do is describe it. And his was the first attempt to take what you could see visually and explain it based on astronomical research. Now, Annals is sometimes compared to the Celestial Handbook, but we believe that what we're doing is quite different because our audience is different. Yeah. Need I say any more? First of all, our modern audience, you guys, have at your disposal larger commercial telescopes, computers, narrowband filters, state-of-the-art multi-element eyepieces, digital and CCD cameras, and powerful imaging technology, not to mention a fire hose of innovative astronomical research, thanks to modern observational and computational astronomy. So our readers also use a wider variety of telescopes and telescope apertures that were available in the good old days. I mean, I started off with I was the guy with the 60 millimeter refractor. I don't even know why I'm still in this business. But this means, though, all these different apertures and telescopes means that our readers not only see different features of the same objects, they see a whole new range of objects that Robert Burnham didn't profile in his book because they were way too faint. So this brings me back to object selection again. Now I've got all these objects to have to look over, and which ones do we choose? We try our best to cover all the bases, but you know, it's hard work. I admit it's hard work. And speaking of bases and hard work, I take inspiration from this sentiment here that came out of A League of Their Own, in which Tom Hanks, in the role of Coach Jimmy Duggan, tells Gina Davis that, of course, baseball is hard. It's supposed to be hard. If it wasn't hard, everyone would do it. The hard is what makes it great. So I printed out these lines and I taped them to a shelf by my computer where I work every day. And I look at it every day, sometimes several times a day. And like I said, it inspires me. I just hope it's true. So, in conclusion, I tend to look at the Annals content selection much as a travel writer does. Travel writers have to write about interesting things to do and see in various parts of the world. And sometimes the things they feature are as obvious as the Eiffel Tower or as obscure as a volcano with a funny sounding name in Iceland. Eyjafjallajökull. There. Yeah, I should have deserved an applause for that. So my job is to do that, be the travel guide, but for all the constellations in the sky, all 88. And we try to point out awe-inspiring celestial formations, a pillar of creation here, a flea-shaped star cloud there, star clusters that look like Mickey Mouse or Cleopatra's diadem or something. Anyway, some guesswork is involved. It simply can't be helped. And you get down to it, I think most of us with an interest in astronomy are generally, or inherently actually, interested by almost anything the night sky has to offer from that standpoint. Second here. Anyway, based on that approach, how can we go wrong? Right? And we could pick almost anything and make it interesting, or at least point out why it's interesting. The problem with that outlook, however, is that it brings us face to face with an existential limiting factor in selecting content from a cosmos of content, which simply put is so many celestial objects, so little time. But that's a sobering reality we all have to face if we are trying to please everybody. Can't be done. And so we just try our best with what we're doing. You take a stab at it, voila. Annals of the Deep Sky, Volume 5, and in which, you know, we can at least say, claim if nothing else, pride in its great bulk, because at 457,000 words and counting, it's bulky. Yes, 457,000 words, last count. That's up through Volume 8, which you won't see for a while yet. Volume 6 is the next one out.
How many pages total are you looking at?
That's one of the questions people ask, as I always say. It's not you won't like that. I don't like thinking about it, frankly. That is one of the things I don't like thinking about. But anyway, that's my talk. Thanks for coming. Thanks for having me. And go out and be brilliant.
This is a rhetorical question, but it's kind of a pet peeve of mine. It seems like every observing catalog is arranged alphabetically by constellation name.
Mm-hmm.
Everybody knows that Cygnus is right next to Bella Pecula in the alphabet.
Mm-hmm. Yeah.
So why don't some of these people arrange it by where they are in the sky?
Well, believe it or not, during some 7 or 8 years we were planning this, we did come up with various formats. One was to arrange them by season. Another was to arrange it by region. We felt that it was less intuitive to do that. When I go for a reference, I want to go right to the reference I want and not have to think about what season it's in or what part of the sky it's in. So we did it alphabetically. Now, one of the other things we did is we didn't arrange it, if you look at the formatting, we don't have brightest objects to faintest objects. We have objects in the galactic and extragalactic realm, not stellar realm, by distance. It's not something I was very happy about doing because it adds another layer of complexity to it. But I think that as you go through and page through, you go to these objects and they get more and more distant and you get an idea. So that was one of the other things we did. We just think that it's easier when you think about Cygnus, where is it in the alphabet? It's easier to find.
Well, I guess that's going to be my pitch for forever.
I hear you.
How did you make the decision on disbursement between your volumes so that your volume 1 had as many interesting things in it as your volume 8 or 3?
Yeah. I don't want to think about it. It's funny. It's just worked out that way. It's just worked out that way. We find that I think there's one star in Andromeda that I could have dropped. I think it was at Delta Andromeda, which is just a wide double star. There's nothing very much more interesting about it. But it just worked out that way. Sometimes we have content that is quite rich. Cygnus, the constellation Cygnus, which is going to be several more volumes down the road, is about 48,000 words. Constellation like Circinus is 4,500 words. Then you add images. I mean, you just have some constellations have a lot of stuff in them and some of them don't. And it just somehow, so far, has worked out. We've sometimes had to bump constellations to the next volume because we've had just too much content. The publisher likes to keep the page content down under 400 pages. I think this is the 390.
That's the fattest one. We basically,
This is the biggest one, right?
so we have 350 pages. And if we're at the end of the constellation, we put that volume.
It's not science, it's just Desperation. Yeah.
Yeah, in your asterism picture, I know you hate asterisms, but in your picture of the coat hanger and Camelos Cascade, if you want to go back to it.
I'll see if I can.
Can you use these asterisms as an excuse to talk about deep sky objects in the same field that are associated with them?
Yeah.
Get yourself, because with the coat hanger, there's a deep sky object on either end of the coat hanger, and
Well, it's in
Camelos ends in 1502.
Camelos Cascades and Camelopardalus, right? And I do talk about it in there, and I profile that cluster.
Yep.
So we talk about, well, the coat hangers, yeah, that's Vulpecula, which I can hardly wait to get to if I live that long. But yeah, I don't know why. My mind was on deep sky objects, stars, and I wasn't thinking about telescopic asterisms. And some people were quite miffed that I kind of dismissed them.
Kind of a new thing.
Yes.
How would you classify or incorporate the Einstein cross in your thinking? And also, I'm very new at this.
No.
Am I going to be able to observe that through my image?
No.
But how would you, would that?
I would. In fact, in volume 6, some of you may have heard of Dragonfly Telescope, the Dragonfly objects that we're seeing. They're like 25, 26 magnitude. I profiled Dragonfly 44, which you cannot see with your telescope. But it's in there because it has a story. It has an astrophysical story to tell about the whole continuum of galactic evolution. Now, the Einstein cross is there are gravitational lenses that can be imaged by amateurs, and we will probably talk about some of those. We haven't gotten to them yet, but yeah, I don't shy away if it's integral to the story of astrophysics and integral to the story of the cosmos, the universe. We'll put it in.
Classified as an asterism?
No.
It's just
Asterisms are just funny little patterns. These stars aren't even near each other. They look like they're near each other, but they're not. Einstein cross is that's a physical gravitational lens type thing. It's other. Any other?
I had more of a process question. So,
Oh dear.
let's say you land on some kind of object that you're going to put in. How do you put the pros around it? I mean,
Where do I start?
where do you start?
Usually in a fetal position. Well, for instance, we did at a Kanipe. That was that's probably one of the longest profiles we did. It's got well over 1,000 research papers. Stuff's coming out all the time. So it's all different. For a big object like that, I just sit down and breathe in and breathe out and break it up into observational history first. Who saw this first? What does it mean? Early telescopic observations, and then that just kind of helps you into the modern stuff. But yeah, when you have over 1,000 papers to pick from, it also helps that these papers sometimes have lots of citation references. So if they're heavily referenced, they're cited, that's a sign that you've got a good paper. You go with that. Sometimes there's not much to say about an object. Burnham, I think for some of these southern constellations, devoted maybe 3 pages to them. And we try not to do that. We try to find objects that are interesting in all of those constellations. But it's just a matter of sitting down, not panicking, and being methodical and going through it one step at a time.
Does your editor trust you then?
Oh, he has to. Oh, I've got him over a barrel. He has to trust me.
Okay.
We have, because I'm the only one who can write this stuff. And we do have readers, people who read. Harold Corwin's one of our readers. Sue French, you may know of her from Sky and Telescope, reads our stuff. I call her the school marm. Brian's, yeah. Well, she's got some eponymous asterisms herself. So, Brian Skiff is the other one from Lowell Observatory. So we have a really good, we have a good background of readers. They catch things that, believe me, there are a lot of moving parts. There's text. You can find yourself way over your head pretty fast. You just have to be very careful. And I think that we're probably one of the better reviewed publications, a lot of astronomy books that are out there, actually. Yes?
I haven't looked at your book yet. Since you're talking about constellations, did you start off by talking about the constellations, history?
Yeah. It's not one of my favorite things to do, but yeah, we talk about the constellation. If there's myth, we pull up some myths and talk about some of the observational history of the stars in there. So yeah, we talk about, you know, when it's visible, probably that's right up at front. Then, you know, who was Coma Berenices? Well, she ended up being a real person, actually. You know, when we talk about the mythology, sometimes there's various mythologies, and believe me, that's another morass to get into because there's so many conflicting mythological tales, and some of them are quite bizarre. I will say that too. So we put them in, and then we get into, you know, open with prominent stars. We do the alpha, almost always alpha, beta, gamma, delta stars, sometimes further on. Then we get into more obscure stars, variable stars, the Miras, the Cepheids. And if they're interesting, if they have, you know, interesting observational history, they go in. Stars are hard to write about. They're dangerous. They're dangerous. They have, you get into astroseismology, seismology, which is vibrations, what mode they're vibrating in, and it can be quite a rabbit hole to go down. But that's our job. Question?
Have you considered including any transitory objects like the comet Shoemaker 11-9 or the Kilonova from last August?
The
No.
Kilonova will be in there, because
That's in.
that's in Greece.
Yes.
Yes.
Yes. That'll be in there because
Planets and comets are not.
planets and comets are not.
It's transitory, but it's in one spot, so we can do that.
Excellent.
Yeah. What she said. We don't deal with solar system stuff. That would be a whole other layer of. I don't even want to think about that. Yeah, I just don't. Yeah.
Sort of a two-part question. Forgive my ignorance of the book, but I have do you guide according to different apertures, and in the same vein, do you also guide according to those types of nebula that are really kind of photographic only and not really visual nebula?
Yeah. Well, we do. We present. Well, for instance, with the North American Nebula, for instance, you know, people go out there and say, "Oh, I can see it." Yeah. I've never been able to see the darn thing. I mean, it's like I can see something there, but I certainly don't see North America.
Would you see,
Yeah.
would you see the flitty, say, in an 18-inch, but not a 10-inch?
Well, you can see it in my 11-inch, if you know exactly where to put it. But yeah, when we talk about any object, deep sky object, we talk about how it looks in various size telescopes. And because it's in Annals, I go to the other observers and get their reports. And which is why anybody out there who wants to submit observer reports to me, I'd be more than happy to hear them. Anything after Cygnus now, because...
Yeah, I found that aperture doesn't quite matter as much as quality, but the good quality 6 will show what a full quality 12 will.
It's a balance between skill,
Yeah.
sky conditions. A good 6-inch can show you, quite a bit if you're in the right kind of sky conditions and your eyes are okay. I mean, and there's a lot of difference of opinion. Quite a difference of opinion in what you can see. I get observer reports all the time that contradict each other.
Then you want to compare them
Well, yeah, right. That's why I try to observe. I try to observe these things myself. Which is why I just don't feel right about writing about it and describing it if I haven't really seen it. Sometimes I can't help it because I'm not in the southern hemisphere. We're looking at doing a series or putting in the series the Magellanic Clouds, and I've seen them a couple of times, but never in detail. And so we're going November to Chile, and we're going to observe down there. We're going to observe with a 28-inch, and see as many things as we can. So that at least makes us a little bit more authentic. It's a lot of work. Yes, sir.
So what role does Denis Webb play in
Denis is our illustrator. He's our lovable. Yeah, he's our lovable illustrator. He is a former NASA engineer, and he does all these great graphics. You know that you can't see it from there, but he does some really fantastic stuff. He shows like binary orbits, and that's his forte. So he's mainly he doesn't do any of the writing except some of the captions, which I tend to work up. He is basically our illustrator. Yeah, and an excellent good one too.
Maybe consider the online version or apps version of your stuff.
Yeah, that comes under the heading of things to do in the future, I think. I would like to see, to me this is an organic thing now. We've started it. I think it'll be around, other people will come back behind it, update it, and it'll just continue. Eventually I see it going online. I see it being, like a Wikipedia thing. Right now that's not in the cards because we're just trying to get these things out in a timely fashion, but perhaps in the future. Yes?
It seems like at the end of the day, there's going to be about 20 volumes. At the rate we're going, that's going to take about another 10 or 12 years.
So you're starting to get existential on me.
Yes. I'm going to be blunt. Are you keeping, in good shape?
Yeah, I'm in pretty good shape, I think. I'm got a birthday in September. I'll be 65, but I feel pretty good. I do exercises when I can.
How's that project on observing all the NGCs?
Yeah, not
Look
mine.
around the room, there's a lot of gray hair.
Oh, I know.
Is there
I
any
feel
way
them.
to make that 10 years, 8 or 6?
I really don't know. I mean, I wish I could answer that with some probabilities or anything, but I really can't. I think I'm looking at. I'm healthy. Yeah, we're making changes that are going to speed things up. I think we'll be able to do that. The other thing is that I'm working on volume 9. See, volume 6 is already coming out, but I'm this far ahead. So I may get there first before the production catches up with me, which would be fine too. But yeah, it's we're not every constellation is like Cygnus. There are a lot of little ones in there. That don't take very long to write at all. I can do those up pretty quickly. It's the big ones, Sagittarius and Scorpius, for instance. That's going to be a big one. Did somebody else have a question? Do I go to a library? I have. Yeah, I've been to the Royal Astronomical Library, but I find that I get most of the sources very reliably from the NASA ADS site. They have papers that go back to 1800s sometimes. You can find a lot of books that are scanned that were written by these long dead astronomers. You can organize these things. The references are always given. And I find that's basically, I don't need to go to a library, pull out the Astrophysical Journal from a shelf and go through it. It's faster and more convenient. I was seeing Burnham, when he wrote his series, he was at an observatory, Lowell Observatory, so he could just walk into the library there and pull anything down that he wanted. We don't have that luxury, but we do have the luxury of the internet, and I find it sufficient. You know, there are some web pages I steer clear of, mainly because there are a lot of crackpots out there. But NASA ADS, NED, SIMBAD, VZR, those are all reliable sources. And you know, what I do is I want the paper, and I get the paper. And very often I'll email the astronomer and say, well, what about this? What about that? And I'll get their responses. So we're getting it all from the horse's mouth, so to speak. Yeah. Yes, yeah. We use all the Herschel archive, all of those places. I love libraries, but it'd take me forever if I had to do that way. I mean, I'd still be on Andromeda probably. Anyway, okay, well, is that it? Oh, uno más.
Background, you said you were doing this for science journalism for 35 years, but what were you trained in?
Journalism.
So not science per se, you got like a degree in journalism.
I have a degree in journalism. That's probably why I can do this, is because I look at this as story to do, people to interview, scientists to interview, stuff to look up. Now I can hold my own with most astronomers. In fact, I've kind of surprised a few of them. They thought I was an astronomer, and it's kind of embarrassing to say I'm not an astronomer. But it's got to be that way, because if you get into astronomy, if you become an astronomer, become any scientist, you have to specialize. So as you become a stellar astronomer who his specialty is finding lithium in old stars. That's all he does. He's looking for lithium in old stars, because the lithium shouldn't be there. But if lithium is in an old star, that's a discovery. But they don't talk about galactic evolution. They don't talk about why there are two populations in globular clusters. So the way I usually put this is that my knowledge, in order to do this, my knowledge of astronomy has to be as wide as the Mississippi, but a few inches deep, maybe a foot or two in some places. And that's the only way anyone can do this. You have to do it. You have to know all about all aspects.
Well, agreed. And it's the same thing, if you were trained in astrophysics, then all the new stuff and all the probes coming from NASA now, how would you be able to interpret by credential all the planetary stuff we have? We didn't have anything on Pluto that was worth much 5 years back.
Exactly.
Right?
Yeah. So I'm an autodidact, I guess. Or a neurotic autodidact, I guess.
That's a journalist.
Yeah. Bless you. Well, does anybody have anything else, or are we done? Okay. Thank you very much.